later will explain why the potential is such an important thing, the ambient potential that something is sitting in or is charged to. But normally the Earth, the surface of the Earth, and the electrosphere above it are charged to a different potential, and so depending on the particular conditions and all, anywhere from 150 to probably a maximum of about. The fact that there is no such activity, that's been falsified now for almost 50 years in physics, particularly with the award of the Nobel Prize to Li and Yang for the prediction of broken symmetry in 1957. It was so profound a change to physics that they awarded the prize the same year it was proven by Wu and crew earlier that year. Later that year they awarded the Nobel Prize. I mean, it was a profound revolution in physics. Around like a ball or a top or something, it's a much more complicated concept. But if I sort of think of it as spin, it's sort of like the spin spins 360 degrees over in the complex plane, then spins 360 degrees in 3 space, real space. Well, while it's over spinning in the 360 over in the time domain, it can absorb energy coming in the fourth axis, because the importance of the time domain, we realize that we have the energy entering 3 space from the time domain. The basic charge, every dipole, and every dipolarity, already accomplishes broken symmetry in both in energy flow in 3 space and in the time domain individually. But there's a 4 space symmetry that's maintained. In other words, exactly as much energy comes in compressed form in the time domain to the charge as leaves it in 3 space in expanded form. So we still maintain the conservation of energy law, but we have also discovered the basic fundamental giant negentropy operation of nature. Every charge has been doing it since the very creation, if it's been around the original matter, some 14 billion years. That's good enough for me. So if it's going to fail, it's going to fail at some time in the future. This mechanism continues. You do not have to put any energy in. Once the broken symmetry is established, it goes forever. That's been in physics since 1957. Now the way you get it to a single charge from the dipole, you realize that in quantum electrodynamics, any isolated observable charge is clustered by virtual charges of opposite sign clustering around it. They have to take into account the shielding of that charge, and they speak of the bare charge plus the observed charge being different numbers because of the shielding. And they calculate that. Standard thing, not Tom Bearden. But if you take one of those virtual charges while it is existing, and you take a differential piece of the so-called isolated observable charge, you have yourself a composite dipole for a moment. That's all right. It's real while it does exist. It's fleeting, but it's real. And there's another one the next moment, another one, and so on. So I can really treat the charge as a set of dipoles, and anything I work out for a dipole applies to the charge. So all the stuff between the agreement between reinterpreting the Whittaker decomposition of the scalar potential, there's a scalar potential between the ends of every dipole. That agrees with a quantum field theory approach, as Mandel and Shaw showed in quantum field theory, using photon theory, but all 4 polarizations of the photon, and also agrees with particle physics. It says you get the energy out of the vacuum. The vacuum exists in time, even if it's not observable. The virtual state does exist, it's just not observable. So if you call 3-space observable, or observable 3-space, then the virtual state actually is a structure, internal structure in time. It's okay. If it's energy up there, it's got a structure, it's got rates of flow, it's got density, all that stuff. It's got differences in intensity, which means a potential. It's got a direction, there's a time direction either into the charge or out of the charge. Now, this, however, dramatically opens up things like physics and chemistry, because in chemistry, in the standard model, they assume equilibrium. The standard U1 model assumes equilibrium. You do not have these disequilibriums. They have not taken into account this fundamental thing we just talked about, that every charge and every dipole already does. Now, if I look at a set of experiments with this type of eye, for example, suppose you tell me that in one of these that I mix an acid and I mix a hydroxide and I get the neutralization. The chemistry agrees with this, the tests show that, but I don't get the heat.
No exothermic reaction.
No exothermic reaction, okay? The problem then is the standard model in equilibrium says you will always get heat. There's nothing wrong with that standard model as long as that space-time remains flat and as long as you didn't have an interaction with the vacuum, that is the time domain, with the virtual state. What you have just proved is that that assumption in the standard model no longer applies. You have experimentally proved that you now have violated, gone outside that model, to a higher form of phenomenology, and you have involved an interaction with a curved space-time and with a local activity of the vacuum. You have involved the supersystem, not the system. The standard model kills the supersystem. It only has 1/3 of the components that are actually interacting. Now, for most cases, when equilibrium is recovered by decay very quickly, that's good enough. When it does not decay quickly but is stabilized, that is not good enough and will not even describe the phenomenology. So what you have further told me is that in the acid and the hydroxide, I have some peculiar properties built in here, wired in the particular acid and hydroxide I've made, that causes them to remain stable in a condition where they normally could not be stable in an equilibrium condition. You have stabilized a disequilibrium condition very precisely. And that means you have a locked-in interaction with curved space-time and with a local vacuum. You have a supersystem situation, not a system situation. You see the approach we're coming from.
It looks to me like the approach we're coming from is that these conventional models, in a sense, are a subset of a larger set.
That's correct.
So what you're doing is you're talking about graduating to a situation where you're enlarging. You're either having to discover the other subsets, or you're having to enlarge the members of your existing subset.
That's right. And fortunately, the models that will allow you to do this, that will fit what you're doing, they do exist. Now, I'll give you what the models are. They're Sachs unified field theory. That means he takes the vacuum. His theory applies from everything from the quarks and quarks inside the nucleon, the gluons, to the whole universe and everything in between. Quantum mechanics and everything, he got it all. And it's engineerable, baby. It's engineerable electromagnetically, but with a different kind of electromagnetics, a higher symmetry electromagnetics. There are several other kinds of electromagnetics that already cover a good part of that. A good one is O3 electrodynamics, which the Alpha Foundation's Institute for Advanced Study has been developing under the leadership of Dr. Myron Evans. Now, we have over 100 papers right now carried on a DOE website. It's restricted to scientists because we didn't want to argue with idiots that said you can't ever have a new model, you can't have a higher symmetry electromagnetics and all that sort of thing. But we can probably arrange with Dave Hamilton to get you guys access to that, since you're not interested in starting a big Kerdog fight. You're interested in what the content is. Another place you can look is SU2 group symmetry electromagnetics. Now, a leading exponent of that is Dr. Barrett. Barrett was one of the founders and movers and shakers behind the ultra-wideband radar. And Barrett handles higher symmetry electromagnetics quite well, very well. So there are models. They were developed over in particle physics for situations where the Maxwell Heaviside theory, the U1 stuff, falls apart, won't work. They were developed specifically to include higher symmetry phenomena, not contained in the U1 model. That's why they were developed. But there's been this tremendous resistance to correcting what's taught in our schools, in our universities. Instead, we still teach all electrical engineers U1, we still teach all the chemists U1, and we meanwhile know we have better electromagnetic systems and more phenomenology available, but the scientific community is dominated by the large output of people trained only in U1 electrodynamics. So we've got to argue with the whole scientific community almost. There's only a small number of people working around these peripheral areas. Some particle physicists, a few guys over here, some people pushing the electromagnetics out into higher symmetry situations. But they do exist.
Causes you to ask the question, is the resistance to examining these new models, is the intellectual entropy strictly intellectual, or is it because if you discover some of these systems and you actually create an applied science for it, you can actually create enormous upheaval in existing industry with its enormous investment in equipment and machinery. I mean, we see that with energy. If there was someone who could actually, on a large scale, produce systems of free energy, my God, you talk about the loss of hundreds of billions of dollars of investment in the electrical infrastructure. So I think it's a really interesting kind of sidebar to all of this, is the fact that they feed each other, I think. I think the actual entropy to really get in and examining these other systems and enlarging our understanding, enlarging the knowledge base, comes from business considerations as much or more as intellectual ones.
Oh, of course, and the scientific community right now is very dominated by, who controls science is who controls their funding. Somebody got to pay the freight. I'm speaking as one that doesn't have a salary because I'm too big of a rebel. But somebody's got to pay the freight. Okay, how do you get the freight paid? If you're a professor at a university, you have very little freedom anymore, contrary to popular opinion. For one, the state, the university demands that you go out and get outside money because, under the overhead and burden rate, the university is going to get at least half of it to help them cover their expenses. So they're very interested in you getting outside money. If you want to get your graduate students funded so you can have graduate students working on their doctorate and all and doing a good job, you've got to get outside funding for that and for their projects. Okay, when you start to do that, when you go out to get these packages down in research already put together, the research that is going to be done is already specified. You don't have any choice about it. It tells you what you're going to do. And they're done up at the level of, the advice comes from the level of the National Academy of Sciences and National Science Foundation and so forth. But the advice comes from the very community that's trained in U1. In the classical electrodynamics, which basically the definitive paper was written in 1865 during the time of the Civil War. It was modified, it actually was curtailed to lesser models 2 times later, one by Heaviside in the 1880s just after Maxwell was dead, and then further his version of the equation, which is what is taught today as Maxwell's equations, were then further symmetrized by symmetrical regauging by Lorentz in the 1880s, and that's what added to symmetry and threw out all the systems out of symmetry. It was an arbitrary decision made by Lorentz in the 1860s because it made the equations easier. You see, otherwise the equations are so nonlinear, the variables are not separated, you've got to use numerical methods. You can't separate the variables and solve the equations in most cases. So it was horrible when you didn't have computers. Today it's not that big a problem. It's a problem for an old guy like me, but for younger guys who go to a good university and get numerical methods and mathematical and so forth on computers, give them a good computer, give them a good program, and okay, numerical methods is no problem. He can number crunch. The computer will do it. He doesn't have to sit there and painfully do it like they had to do it back in the 1880s. So they did it for a reason, but they threw out the baby with the bathwater. They threw out exactly a whole class of Maxwellian systems permitted by nature that are not in equilibrium with their external environment. The external environment being precisely the other 2 components of the supersystem, the active local vacuum and the curved spacetime. See, we didn't have, the electron hadn't even been discovered then. The atom hadn't been discovered. None of this non-abelian stuff, except maybe as an idle curiosity, none of that was even born yet. We didn't have the models. What we had was a problem of trying to understand anything at all about electromagnetics and trying to communicate, as Heaviside pointed out, with what were then called electricians, not electrical engineers, and they were about the education of an electrician today. And he said, you'll never get quaternions across to them that Maxwell wrote his stuff in. You got to get it simpler. So he chopped it with a broad axe. And then when Lorentz came in and further symmetry, he chopped it again, and it only contained those systems assumed to be in equilibrium or very near equilibrium with their external environment. So we have built a whole class of systems and procedures and models throughout physics and throughout chemistry and all these other things depending on electromagnetics based on equilibrium conditions. And as long as that system restores its equilibrium very rapidly, then the present physics model is quite sufficient. And the present U1 electrodynamics model is quite sufficient. And the present chemistry model is quite sufficient. When it doesn't recover symmetry almost immediately, very quickly, so that there's not much effects at all from disequilibrium, if it minimizes all its disequilibrium effects, the other models are adequate. If it does not minimize disequilibrium effect, particularly if it stabilizes the disequilibrium structures and the dynamics, then the other models fall apart. They are incapable of describing that kind of condition. So we've got to go to the models that can handle it, and that's the higher symmetry electromagnetics, which haven't been factored into chemistry very much yet either. So we're caught in a situation where we're using 100-and-something-year-old stuff, and it's been modified and curtailed. There's been one hell of a lot of physics discovered since then. There's been a lot of things discovered in electrodynamics since then so that we could model some of this higher physical phenomena, and it hasn't been added into the standard electrodynamics model, and it hasn't been added into chemistry. That's your problem.
Here's why I think we may be on the precipice of something revolutionary. The natural evolution of the development of a science is that you have your theories, and theories work their way into people with more practical minds to create the applied science.
That's correct.
Usually a lag time there. Lag time certainly between Einstein's theory of relativity of 1905 and working its way into the creation of nuclear energy, for instance, by way of example. I think what you have right now is a rather unusual situation where you have the development of the applied science before the genesis of the theoretical structure.
Exactly.
Or at least in light of all these other theories that you've been enlightening about. Let me just say that it's possible that you have the introduction of the applied science before you have the suturing of all of these fragmentary theories which would help to create a kind of cohesive theoretical structure to provide it with, greater theoretical legitimacy, if you will.
Exactly, and what you run into is, now speak of human beings. Scientists are, after all, human beings. They have all the same reactions of normal human beings. There's nothing highly superior about being a scientist. That means they form a bell-shaped curve just like any other group of people. Now,
yeah, they like to joke that 50% of all physicists graduated in the bottom half of their class.
That's correct. Then, let's talk about what caliber of people they are. I know from the bell-shaped curve that they fit. There's a certain percentage of them up on the higher end of the curve that are almost angelic, highly moral, highly dedicated to the scientific method. We'll always try to take a model, for example, into account. Is that modelable by my model or not? Now, the broad band is not going to question the models or talk about models. They're just going to be applying and doing their job and using physics as it has been developed to the best of their ability. They're going to be good physicists, good scientists, doing good work, but they're not going to be creating you a new model, and they're not going to be questioning the model you're working in. Now, the lower end of those people are just about like devils. They have absolutely no morals. They have no dedication to the scientific method. They wouldn't even recognize the spelling of it. They're manipulative. They'll do anything they have to do to human systems or otherwise to climb the ladder and get as high up as they can in control, and they're driven by greed, power, prestige, money, all the other good stuff. Who's going to be the big monkey? Is their driving motif from the moment they get up in the morning till the time they go to bed at night, and then when they dream at night, they're still in the same motif. Okay, the problem with those is they skew the curve. Because of their manipulations and scheming and conniving and all this, they do tend to scamper up and bias the bell-shaped curve. Now, they don't bias it completely, thank God, because we still got a lot of good scientists, and we still got a scientific method, and we still got a scientific community. But they do everything they can to turn it into a dogma and a religion. Now, when the money has to start passing through their hands, and there's more of these up at these higher levels where we get our hands on the money, that's where the power is in any human system. Control the money, you control the system. The more they get up higher in positions in that, then they're able to influence and control a much vaster part of science than we would be comfortable with. They're turning it into dogma, and that has progressed far too far along the line.
So they have a disproportionate voice.
That's correct. They have a disproportionate voice. The other thing is they attack anything that's out of the box that they're comfortable in, and they know. They attack it with a viciousness seldom seen in science. The recent viciousness of the attacks on cold fusion is one example. The attacks on anybody like me, for example, and I consider myself a poor example. I'm not a super scientist. I'm just a guy that looks at models and looks at what they contain and what they don't contain. That's basically what I do. But they attack anybody who's working out of the box as if he were an utter raving lunatic and as if the science were perfect and it were a religion brought down on the stone tablets with Moses or something. That's the problem. You're up against dogma, not scientific method. Scientific method is very clear. If the experiment is done and done well and properly, and if it is repeatable and it repeats the results, and those results fall outside the present model, the scientific method says you must change the model. That's not Tom Bearden, that's scientific method. Now, when you say, we're going to attack you fiercely, and we're going to say, you know, the experiment is wrong, I don't care how many people replicated it, I don't care what you did, you're wrong, the experiment is wrong, and you're a lunatic for even bringing it to my attention, get out of my face, that is not science. That's dogma. And you're dealing with people who want to manipulate it right where it is and very happy in their cushy position. You're threatening to them. You're going to change the situation, the status quo. You don't like that at all. That's your problem.
Interesting.
You're going to change the situation, the status quo. You don't like that at all. That's your problem.
Interesting.
And of course, you know, you can put all kind of quotations from eminent scientists on that. You know, Feynman, for example, says, you know, most of the things that we list as givens in science, we don't even know what they are. We don't know what energy is. There's not an adequate definition of force. And he said, try it. If you think there is, try to find one. You won't find it. If you really look at the problem. I couldn't find a single physicist or a single physics dictionary, and I bought the best that was available that adequately defined the potential. And the reason was quite simple. They don't calculate the potential. There is not a university in the United States that has ever calculated the magnitude of a potential. There's not an electrical engineer or a grad student. What they calculate is what is diverged from the potential by a unit point charge that you just arbitrarily stick there in space. Now, before the charge is there and before the interaction, what exists there? It's not the E field and it's not the potential that you have in your textbook. At best, that's a real careful scientist will say potential intensity. That's an indication of the intensity of the potential, not what the magnitude. The magnitude of the thing reaches through all space. So what's its magnitude? Same thing with the field. The imprecision that has been fostered in there, like all electrical engineers talk about drawing power. You can't draw power from the wall. Power is the time rate of doing work, and the work is time rate of changing the energy, or like scattering it or dissipating it in a resistor. And that's in the local component. It has nothing to do with what comes out of the wall. The other thing, energy flow, has nothing to do with the electrons coming out of the wall and flowing as current. That's the energy dissipation going on in the circuit. It has to do with that. The energy flow is outside the wire. Even the standard pointing theory goes into that, and if it reaches on into space, out way past the wire. Pointing never considered anything except the amount that hits the surface charges and gets caught and drawn back into the charge. It actually hits the field from the surface charges and gets drawn back in to the wire, back and forth. That little bit gets added to the wire. It's a tiny bit of the energy that's out there. Heaviside, the independent co-discoverer of so-called energy flow through space, which has got to be changed, by the way, it disagrees with quantum mechanics. The energy flow in the observation itself, the energy flow does not actually conclude just the amount that's caught, just the diverged pointing component. It also includes a component that does not get caught and does not get diverged and misses the circuit. It's enormously greater than the other one. But now back in the 1880s, you had a problem. If you came up and you said that the terminals of every generator and every battery out there, that from the terminals there comes this outpouring of energy far greater than the amount of mechanical shaft energy input to the generator or the amount of chemical energy dissipated in the battery, you would have been violently attacked by the small scientific community that there was. It was only about 3 dozen electrodynamicists in the whole world. You would have been violently attacked as being a perpetual motion nut. So they had to be very careful with it. Now, Lorentz understood the difference between both sets of theory. Heaviside was better. Pointing got the direction wrong. Heaviside corrected him. But Pointing published prestigiously. Heaviside was self-taught, brilliant man, but self-taught, never went to university. He published more obscurely. He later got a prestigious publication in Royal Society proceedings, as were Pointing published. But he spoke of it in terms of angles. He's very cautious not to say there's a hell of a lot more energy pouring out of those terminals than we're putting in that thing, so what's happening? Lorentz took a look at it and said, my God, how do I explain that? Even the great Lorentz could not dare to say, there's 10 to some number. You grab a number, 12. I did an estimate 1 on one circuit, was 10 to the 13th. But say 10 to the 12th is as much energy pouring out of the end of the generator as you're putting into the shaft. Now try to run that by an electrical engineer. It's true, but just try to run it by one. Lorentz said, well, this other energy, he never denied it existed. It doesn't do anything, and he used a clever phrase. He said, it has no physical significance, but it doesn't power anything. That's like saying I got a sailboat on the ocean. big wind, and all the wind misses my sails, have no physical significance. That's true for my boat. For those sails on my boat. That's true. The rest of that wind doesn't power my boat at all. So he said it has no physical significance. He gave a little trick to integrate the whole energy flow vector around a closed surface, around any volume element of interest at all. That throws away everything that goes in and comes out with no diversion. It throws away the Heaviside component. Retains a pointing component. Now that'll agree with your measurements on the circuit. Because energy that's dissipated from the circuit, which is what you've got to measure, has to enter the circuit, and that's the pointing component. It's not the Heaviside component, which does not enter the circuit. The average electrical engineer, it's a rare one, very rare, I would say less than 10 in the United States, even knows there is a Heaviside component missing the circuit. He never looked at it, has nothing to do with it, doesn't believe it if you tell him. Never has read the original papers. Never has gone back to see what Heaviside actually said in his papers, or what Poynting actually said in his, or what Lorentz said in his. Most of the professors have not read the original papers. Over 50% have not read them. They don't think it's necessary anymore. The perfect job was done. It wasn't. So, in every area we look at, there again was the broken symmetry of the dipole. Batteries and generators do not power circuits, never have, never will. There's not a battery, there's not a generator ever made that added a single watt to the power line. It's very easy to prove that in particle physics. It doesn't even exist in electrical engineering. In fact, they'll think you're nuts. Let's explain it. From particle physics. Starting from the award of the Nobel Prize in 1957 for the broken symmetry of opposite charges. Now, a dipole is two opposite charges very close to each other. That's what a dipole is. So if I've got broken symmetry of opposite charges, baby, I got broken symmetry anytime I form a dipole. I don't have to prove that. It's been proven in physics. If anybody doesn't believe it, go read why Li and Yang got the Nobel Prize in 1957 and read the papers. Read the literature. That's gotten unfashionable these days. Don't read the literature. Read what somebody wrote about the literature. No, go to the original sources. Okay, once I have this dipole, the very definition of broken symmetry says whatever is virtual, the virtual particle interaction coming in with those charges, at least a good part of that is being changed over now and is re-radiated back as not as virtual form, but as observable form. All that is coming in a time domain, which is virtual state structures of time, and re-radiating out by integrating by the spin to real stuff, just like an old, for first order analogy, just like an old spinning wheel weaving threads together, fibers together into a thread. You get them bigger, they become observable, but then they're three-space because you see them. That means you catch them in three-space. So what happens is, that's what the charge is doing anyway, and that's where it's coming from. But we know that once we form that source dipole, now leave it alone. Don't ever put another watt back into the circuit at all. That dipole will sit there and pour out energy forever, including both the Heaviside component and the pointing component. Now, clever devils that we are, we've been using a 100-and-something-year-old system. Whatever we catch in that circuit, we want to drive the electrons around in a circle. We ignore the holes in the Dirac sea because they mostly interact with the lattice holes, which are tied to big old ions down in the nucleus, for example, and there's so much heavier than an electron, they rock a little bit while the electrons are going. So what we do is we ignore a whole part of the electromagnetics going on, usually, in power engineering particularly, and what we do, whatever we catch potentializing these electrons, we look at the back EMF between the source dipole. Every electron flow that's potentialized and goes around this way down to the ground side, we have to pump its equivalent right back up through that back EMF and knock the charges apart. So it takes precisely one half the energy it does collect to destroy its own dipole that's pulling the energy out of the vacuum to power the circuit. The other half powers the circuit. It powers the losses and loads, which means less than half in a real circuit with losses. Less than half is actually developed as power in the load. You got a half used to kill the dipole. You got less than a half used to power the load. You got to put back in at least as much to work back on those charges and force them back apart to make the dipole again as it took to destroy it. So you got to put more in than you get out the load. And that's the only reason on God's green earth we're building COP less than one circuit. Universally. Closed current loop circuit restores Lorentz symmetry. and forces us into COP less than 1. Forces us into classical equilibrium thermodynamics, forces us into the second law of thermo, and baby, you can't beat it. If you have an open system, a common home heat pump, for example, has under good conditions, has a COP of about 4.0. Theoretical maximum is 8.22. But the average one with its inefficiencies and all is about 4. It puts out about 4 times as much actual energy delivered in, heating the air, or pumping the air, or whatever, or cooling the air, as you have to physically put in electromagnetic form. It gets the rest of it by compressing the air and taking out the energy out of its external environment. It's an open system, perfectly permitted to do COP1. The only reason we don't closed-loop heat pumps and self-power our homes is because they're diabolically designed so you can't have a high-efficiency process. You've got to have the low efficiency. There have been high efficiencies when patented, and they disappear. Because when it cools off out there, bingo, now you're back on resistance heating. They lose so much efficiency you can't get anything out of them. You got to go to a resistor. So now you burn power. Everything has been designed to keep that power meter on your house and keep that gas pump meter on your gas pump and keep you out of an electric car. Doesn't have to be designed that way, but it's been designed that way deliberately. Now, the electrical engineers don't know it. The electrical engineer doesn't even know about the Heaviside theory. It's a very rare one that has ever read the original papers in the first place, and he didn't pay any attention to the fact there's a hell of a lot more energy coming out of the terminals of a battery or generator than what we're putting in the shaft or the chemical energy we expended. It never registered. Now that's appalling after 100 years, over 100, 1880s. It's appalling. Why is not the National Science Foundation reacting to this? I don't know. Why is not the National Academy of Science? Well, for one thing, it's prestigious. You get elected to the National Academy of Sciences, and you're not fixing to pull the rug out from under your prestige and what you've done. No way. You're going to see it's done a little better. Commend the young guys on doing better research, make it a little more efficient, but you're not going to go throw out the whole system and start a new one. That's the problem. We have now, really, it's not diabolical, it's honest. But what it is the whole scientific community, is, the bulk of it is dedicated to maintaining the status quo. Mm-hmm. And that's what's wrong with us. We're still using an archaic science. We're still affecting what the chemist is allowed to do because we're giving him a U1 model. And we're teaching him U1 electrodynamics. He never heard, most of them, of these higher symmetry electromagnetics. And certainly, I don't know of any chemical textbooks using them. There should be. They've been around a long time. Why are we not funding deliberate research to get outside the box, to get outside the present model, so we can get new chemistry? We can get marvelous advances in chemistry, such as this thing. Why aren't we doing that? I don't know. Because we upset somebody's rice bowl when we do. And they don't want their rice bowls upset. That's basically what it's all about.
Yeah, we're getting it in droves.
I'll give you one more thing and then this will be over. When you deal with the supersystem, you now have to understand engines. I'm going to start in general relativity. In general relativity, if I change the local energy density of the vacuum in any form, whether it's mass or whatever, any form of energy that I change, the energy density of this local space right here, this little position, I immediately have a curvature of space-time. That's the way it's modeled. I'm talking about a model. Now, curvature of space-time is not just an etheric kind of idea that'll go away and not bite you. It's a very active, dynamic thing. Space-time is considered to be the active thing, and I'm glad it is because time is the part of it that's really active, giving us all the energy. So they got it in there, but they call it space-time. They call the part that isn't changing, really, from the repeated observation, but the part that is. So, but once I have a curvature of space-time, I now have, I'll quote Wheeler's principle. If I change the mass energy, they speak of the energy in the mass rather than the mass. If I change the mass energy in density, I change space-time. I affect space-time. I cannot avoid that interaction. It's absolutely automatic. Now, if I change the space-time curvature, and there's a mass sitting there, I affect the mass, and I change the mass. Now, you can get new mass. In a curved space-time, a photon has mass. The photon interactions with that mass now can add mass or subtract mass. You get my drift? You can have in this, if I take the exact template, the exact forms of all the dynamics and all the curvatures, I call that a template, and the dynamics, I call that an engine. Because if I change the space-time itself, which I can do electromagnetically with these higher symmetry electrode, I can't do it with U1, because it assumes a flat space-time, don't have an engine. But if I use one of the others, I can have an engine. I can make it in space-time without a piece of mass even there. Then I can bring in a piece of mass and it'll baby work on that dude until that mass changes to where how it would affect space-time fits that curvature, and that curvature working on it fits what it is. Till that balance occurs between curved space-time and that. The engine works forever and you don't have to provide any energy from it. It takes it from the whole universe, space-time itself. So you must understand the engine concept. Now that I'm talking about the supersystem, I have engines. Now the engines exist in the vacuum. I don't have a linear vacuum. I have structures in the vacuum which will work on those charges, move them around, change their charge, change a negative charge into a positive charge, all kinds of things. Now the lab observer, looking from his flat space-time at that, is going to see the intersection in flat space-time of that thing. He's not going to see that thing in curved space-time. If I started with a standard set of something that I can model in a relatively flat space-time, and I make a peak in it somewhere where it violates that, now if I change this whole thing, I've still got my peak. I didn't change what I started from. So you will recognize in your chemicals, in your molecules that you form, you will recognize the peaks of certain things that, well, it's just sulfuric acid. No, it's not. It would be sulfuric acid if you unkinked the space-time and got rid of the engine. But as long as that engine is residing in that set of atoms and all making up that molecule, you do not have to have just the model that exists in the normal stuff. For example, what would be unstable in equilibrium conditions? This is not equilibrium. Curved space-time is a broken equilibrium, a very fundamental one. And you do not have to have what you have in the equilibrium conditions. And it can be stable as long as that curved space-time is stable. The business of charging one in the time domain, you can have it charged for an awful long time. You can just hold that and stay there and sit on the shelf and all this. It doesn't have to decay. When it does decay, it decays very slowly, usually, unless you take special measures to convert it. But yes, what you're doing is really using engines. Now, it can be modeled, it can be accurately expressed, including the exact molecule you form, if we change the chemistry to add engines, to add curved spacetimes, to add active vacuum going on all at the time. If you get a balance between the stuff coming out of the vacuum and the stuff coming from spacetime, that the only place they're in equilibrium is where this crazy molecule exists, that molecule will exist. It'll lock in. You see what I mean? You got yourself a symmetrical condition, but look at the symmetry between curved space-time and the vacuum. It's not the symmetry that we normally look at. Forget the space-time and forget the vacuum. Look at 3-space. We're not looking at 3-space. We're in 4 dimensions. Or if you want to, you can be in 11 or 12. Depends on what you want to use to model it. So you can have a molecule which is absolutely unstable in the present situation. Present model would be totally unstable. But if you have violated that model and you have achieved a balance between these other two components of the supersystem, then you can lock it into stability in what the guy in the lab will see would be a terribly unstable condition. It will not be unstable. Now, he's not wrong. He just hasn't realized that he's wrong in his model. He would be correct if you were using the situation described in his model, assumed in his model. The background conditions, the initial conditions and all that, automatically assumed in his model. If you were applying those, then you could not be doing this and he would be right. Since you are not using those conditions, you have deliberately changed them by adding an engine, making an engine. Once you have the balanced engine between the time domain, the curvature of space-time, actually the time domain in a curved space-time, and the interaction from the vacuum. Once you have a balanced equilibrium there, that will hold that state even though it would be normally unstable. It'll be just stable as a rock. Under its conditions, that is a special form of symmetry. Not in 3 space where the normal chemist is looking, but between the space-time, curved space-time itself, and the local vacuum. That's where the symmetry is coming in. Whatever happens to it from space-time is balanced by what the opposite being happening. That stabilizes it, holds it right there. It's in an equilibrium condition. So yes, this is the way you have to explain what you're doing. Now, how do you get that done scientifically? You don't have a lot of choices of people that can handle that kind of electrodynamics, but you do have them. They are available. You got to be sure you got a couple of them. Terry Barrett, Myron Evans is out of it because Myron has a genetic problem. He's in Wales right now anyway, and he's being taken care of. But he's one of the most brilliant minds on this planet, so you could use him for consulting purposes. He also is a chemical physicist. He knows not only the physics and all this other stuff and all the higher symmetry electromagnetics, he's a founder of that, but he also knows chemistry. So he'd be an ideal consultant. Terry Barrett can handle all this higher symmetry electromagnetics, and he can hang in there with all of this. So you have to have people that know general relativity, know unified field theory, where there's a higher symmetry electromagnetics developed, so that you can unify. You can't unify U1 electrodynamics with general relativity. They're diabolically opposed. One says the space-time is flat, and the other one says no, it ain't. It's curved. You can't put 2 things like that together. They don't fit. So, you know, in country boy language, they're stupid to try to fit them. They don't fit. And nature's unified. Nature doesn't have it separated where they never get together and never operate at the same time. That's not true. Nature has them always operating. So what you're doing, as far as I'm concerned, is magnificent, but you're advancing chemistry out of a flat space-time, no vacuum interaction model into a non-abelian model where you have a unified field theory model where you have both a curved space-time and you have an active vacuum interacting with that system itself, with that chemical system itself, with those molecules themselves. If you manipulate the charges, baby, and change the engine they're using, you can change what molecule they will form and be stable. And that's what you're doing. Can all be described with good theory. It will not fit the chemical model in most of those chemists' heads. It never will. Because you're not doing that. You're outside their model working. It's okay. That's what advancing science is called. And in the scientific method, we're supposed to do precisely that if the experiments are replicable and done well. If they continue to be replicated and give results that refute the present model, all they're telling us is we've got to change our model. Nature works this way, now go model it this way. That's what they're telling us. That's scientific method. That's the advance of science. So that's what ought to be done.